We're just going to get started here right away because we have a lot to go through. Actually, not a whole lot of content as far as theory, but it's going to be mostly me modeling, doing some demos for you, how to approach polygonal subdividing in Maya. So this is when we really start modeling more. So last time you did a piece of furniture, more of a hard surface asset, without actually subdividing too much. So let's get started. We're gonna just see how we can work in defining the curvature using creasing edges. Creasing edges being edges that are not really the contours of the mesh, but it's just additional edge loops that we introduce to hold curvature. So we're gonna just start looking at that and how do we define poly cages. Yeah. And then we're going to spend, like I said today, most of the time me just modeling something. I'm often going to start, you're going to see me start out from polygonal planes at first, and instead of starting out with a cube. So we don't have to worry about the thickness right away. So for the lab assignment, what I want you to do till next time again is that you're going to just model some simple assets for your kitchen. You're going to model a spoon, you're going to model a plate, and a teacup. And then you're going to model a teapot. Okay, that's basically what I'm going to be modeling right now, and that's what I want you to do. Okay. So let's just have a look at subdividing. Oh, and again, my whole Maya has to be. I guess I could have saved my preferences, but. So last time, the whole thing we did with subdividing is that I asked you to press number 3 to see if all the vertices were merged, right? So as long as the vertices were merged, you get a nice coherent mesh. Everything just sticks together nicely. You know, if one of the vertices were unmerged, like we saw last time, you would get strange effects. So we go to edit mesh, detach the vertex, then no longer a proper subdivided result, right? So as long as all the vertices are merged, you will see a very predictable result when you hit number 3. So we're going to talk about what actually establishes this curvature. So it used to be, like way back, if you really wanted to do any sort of very nice curved assets, you would opt for curves and NURBS. So that's the whole thing here that Maya calls surfaces. This deals with curved surfaces. So they're not polygonal objects, but they're curved surfaces. So that, like I said, that used to be the case if you wanted to do anything that doesn't look like a square or very hard-edged models. And then there's also subdivs, which is in between the two. So here you can see we can actually convert polygons to subdiv surfaces. So just to be clear, that's not what I'm going to be doing. I'm just using sort of the inbuilt smooth preview. So I'm pressing number 3. Okay, so it just means that there's a few things that happen. So let's look at what actually happens. So if I copy this, we have the function up here. This is basically what happens. So we can smooth the object. And so two things. It quadruples the poly count. So if we open up the poly count again, that's one thing it does. Wherever there's 1 poly, now there's 4. So right. It quadruples the poly count and it introduces continuity curvature. It used to be that we could, I guess we gotta. Anyways, this is probably, you'd have to go into the legacy one. Anyways, it used to be that you could turn off the continuity, but we don't have to do that. But anyways, it introduces a curvature and it quadruples the polys for each division. So if I divide it again, hit two divisions in the smooth, it's gonna quadruple the poly count again. So wherever there's a poly, now there's 4 more. So if we press number 3 on this one, you can see that this looks very similar. If you take a look at the contours, you see that they're a little bit, you can actually see the polys. So it is actually the same. So if we go in here and take a look, again, Control A to go to the attribute editor. If you go to the smooth mesh, this is to control the smooth mesh preview. So when I hit number 3, that's just the smooth mesh preview. So you can see, yeah, this is set to 2 divisions, right? So it's actually the exact same thing, except that here I can no longer just easily go back to by hitting number 1 because I've committed to the shape. Okay, so but interestingly, if I hit number 1 here, I can go back and forth between these, and this is what we want to do when we're modeling. Because if I do this too soon, I'm stuck with this shape. But what do you think if I hit number 3 on both? What's going to happen? It's the same. They're going to yield the same results. It's just that this one we've now committed to. But you see, when I subdivide this again, pressing number 3, it's going to add those divisions again, so causing a very smooth object. But in appearance, they're very similar. So that's basically what the smooth mesh preview is actually doing when you hit number 3. So if you wanted that to be more smooth, you can add more divisions here in the attribute editor if you wanted to. So I can add 3. You can see that now becomes more smooth. That's also something that you could do in the end, like when you're rendering, when we're getting the images out of Maya. If you wanted more smooth meshes, you can go ahead and do that. Okay, so what about the curvature? What is deciding the curvature? Well, all we have are vertices, right? Vertex points. So to compare this, I'd like to draw a curve. So we still, also in polygonal modeling, often use curves, and I'm also going to be using the surfaces today a little bit later. But let's draw a curve. So this is the most common curve tool, the CV curve tool. CV just stands for control vertex. So beneficial to use one of the orthographic views. So I'm just going to go to the side view. Hit Alt B, so different backgrounds you can see. And then, I could start drawing out a curve. So place a point, place another point. So if you notice, there's a straight version of the curve. That's what's defining the curvature. And then we get a nice curve out of that. I'm just doing this to show you the similarities actually between these two approaches, because if I just have a standard polygonal cube here, I'm actually just going to use a plane. So now in the side view, this is going to be hard to see. But let me go in here and I'll grab this edge. And I'm going to find the extrude face. I'm going to make a hotkey on Control E. So if I go to the side view here, so I have that edge selected, so I can just start extruding. So in a very similar fashion, I can draw this out. This not being a curve, but it's actually just a polygonal object, right? It's just that plane is now being extruded. I'm just extruding that edge. So if I go to object mode and I hit number 3, I can make that in effect into a curve. And the curvature is based on the placement of the vertex points. So it's the same thing here when we're drawing a standard curve. We're using control vertex points to define the curvature. Here we're using vertices to define the curvature when you subdivide. So just to show you, it's very similar. It's just that now we're dealing with polygonal meshes. And there's a few benefits to doing that versus using surfaces. So now we have all these vertices. They're spaced evenly apart. It just causes this rounded off effect. But we could go to the insert edge loop tool again. Let me just find it. Let's make another. Sorry about this, having to do this over and over again, but at least you see it again. So insert edge loop tool. So if I just freely place an edge, press number 3, you see that, okay, so that has an effect on the subdivided result. I can move that edge around so we can see what it does. So pressing number 1, I can only see the polygon. Pressing number 2, I can see the poly cage and the subdivided result at the same time. You have to be a little bit mindful when you're doing this, or not this, but if you're going to number 3 and just move this edge around, because it can look okay, you know, say, you like that shape, but actually you're creating a mesh that's not legal. So sometimes if you press number 3, like I wouldn't advise you to only be working in this mode. You have to make sure your polygonal mesh is also legal. All right. Okay, so we can see that by placing that edge closer, now this side of the curvature is not so round, because these vertices are now closer together. So whenever you want to define curvature, we need at least 3 points, right? That's how we ideally define the curvature. So up here, if I place another one here, you can see that now I have 3 points that are much closer together. So if I press number 3, this curvature is now being defined by these 3 points. So I'm able to hold that corner. So you can see all these other corners are rounded off, but this one is very sharp because these vertices are close together. These vertices, you can see this curvature is now being defined by these 3 points, resulting in this curvature, right? So, but, you know, so I could just keep going here if I insert edge loops all the way around so that I have something like this, and then also over here. So now you can see each of these corners are defined by 3 edges. So if I press number 3, we get that. So that's the, sorry about the sound in here, it's horrible. That shape though is very similar to what we did last time, where we just did a bevel. And we did a bevel with 2 segments, right? So you see that's, if you take a look at the poly count, I have 54 faces. Yeah, here and here. So it's the exact same poly count, it's the exact same solution, except that with the bevel operation, we get the added little benefit of having these vertices being rounded off, which these will be when we subdivide. You know, it's not that different. So if you are doing something like this, we can bevel, and then just to get those creasing edges, which is in effect what we get. And then if you wanted to, you could also just subdivide this, you know, pressing number 3 on this, subdividing this. Any questions? The nature of this, how we can define curvature? Yeah. I'm sorry? One of the edge loops? This? Okay, so you just double click it to select it. Now that selects the whole edge loop. So you want to make sure you're in edge mode, then double click. And I can go to move tool and just move it. I could also select the vertices, so move those. Yep. Yeah, we could have. Let's just start modeling something, because there's just going to be a lot to explain and as I go. Okay. And you're still not on the server, right? Don't know. No. So I'm creating a new Maya project, and I'm going to save. Let's make a spoon. Wonderful. Okay, so as last time, I'm not going to bother finding very precise orthographic images. We're just going to find a spoon. Perfect. So I'm going to drop this temporarily in the images because I might have to do something to it. Yeah. So I'm going to just model a version of this spoon very quickly. And then there's no recipe for how to model a spoon. There's several different ways that you could do it. Several different approaches, but I'm going to start out from a plane and just rough this shape out and worry about the thickness in it in the second stage. So that's basically what I want you to be practicing. It's this workflow, starting out with flat models. All right, so I'm just going to make a 1x1 image. I always just like to do that. So how large is this one? All right, so a little 512 by 512 should be okay. So that's half a K, half K. And then Control A, Control C, Control V. Oops, scale it down a little bit. All right, there we go. So that's all I need. Save this as whatever, PNG. And then this time I'm going to put that directly in the source images because that's where Maya wants the files that go directly into material. So this is the spoon ref. So I'm going to make a plane. Let me turn off all these divisions. I'm going to make a surface shader. Make a file node, turn off the filter type, and there's the spoon ref. Press number 6. So when you rotate, there's a nifty little feature. If you press E, that's like, QWE. If you press E, which is the hotkey for the rotate tool, and then you hold it, and then you press left mouse button and hold it, you will get some more options for the tool. So this is for all the translational tools. So here we have discrete rotate. When that is on, it's just going to snap rotate. So I can snap in increments if I wanted just a quick way to rotate the spoon. Okay, so again, if you want to, you can try to find more accurate references. I'm not going to bother. I'm happy. And it's a nice little challenge for you trying to model something, again, I think, without necessarily having super detailed measurements. But for the, let's see, kitchen spoon measurements. If you want it to be accurate, maybe we'll find something. Handy kitchen measures. That's nice. Okay, 1 tablespoon. Never mind. Centimeter. What do you think? How long is whatever. I don't know. Okay, let's do what Adrian says. 17 centimeters. So I guess I can model it like standing up. So we're gonna do 17 centimeters. Yep, that sounds about right. I don't know. Let's just do, or not. I don't know. So yeah, if it's yeah, I don't know if it's a. Let's just get started. Whatever. Find some measurements. Okay, so I'm gonna basically do this from a plane. That's what I was saying. So I could do a measurement cube and the whole thing like I did last time. I'm not gonna do that. So we just have a plane. Let me just set this up. Let me freeze transformation, center pivot. So we add these things that are very nifty. Holding X, I can snap this to the middle of the grid. So this is what you want to make sure, you're working centered in the grid. For all these assets that you're going to be doing, work centered in the grid, work structurally. And the C-axis should be pointing forward. The X-axis should always be the width. And you're good. Okay, so let's just get started. So I'm going to grab these words and just start modeling. Whoops. Don't go there. So literally, just roughing out the shape that I see. So I'm going to Control E. Let's go to the front view. So here I can, if I hold just quickly, I can hold Control and scale pressing this axis, or I could grab this axis. Okay, so there's a crude version of this shape. So, it's not a whole lot of thought that went into this. We could have experimented more with the solution, but the point here is I can subdivide this pressing number 3. You won't really get an accurate look at what that's going to look like with thickness until we do thickness. So first I established a shape in a flat manner, and then I can, just to show you now, I can go to object mode and I can extrude this whole thing in object mode. If I drag this out, this is going to give me the thickness. So then if I subdivide this, this is what it's going to look like. So it's just easier, especially if you're doing complex shapes, because what we're going to do here, this is obviously just one of the axes, right? We're looking at it and we're deciding the y and x axes. But we're going to have to worry about the other axis as well. And we're going to be creating a little more complex shape. So if you want more edge loops, you can just add more edge loops. Move them around, grabbing the verts. Oops. So let's go to the front view. I'm going to use the perspective view. So I want, let's just start inserting some of these shapes. Okay. Brilliant. So now this would be a little tricky if you did this from starting with thickness, because now I can extrude in object mode. I can use this local C, which will drag all the polys according to their normal. Sometimes you can get a more, it's easier to achieve a more uniform thickness by using the actual thickness function. And you can also insert numerical numbers if you need to be very more specific. But you can see I can get a very even thickness all throughout this object. So imagine if I started out with a cube extruding. I mean, I can achieve that in this case, but sometimes it's harder to do that. So this is a little more elegant because, yeah, we don't have to worry about the thickness yet, so we just wait. We just work flat. This is subdivided, you know, so you keep working this mesh. So this is where I'm saying this is not a recipe for how to model a spoon, because there's several solutions to it. It's not like, it's hard to say that something is a wrong solution or a right solution. Now when we're talking about the topology, which is this pattern that all these polygons make, this is what you're going to have to get used to when you're modeling. Is that sometimes if you see yourself being stuck and you feel that it's becomes a very hard process, probably you're on the wrong path. So oftentimes it's easier just to start over and see if you can achieve the same shape in a more simple way. Okay, so let's experiment with this. So how can we get an edge loop? How can we define this curvature a little bit more just using creasing edges? Well, we saw that we could insert edge loops, so I could start doing this and insert an edge loop here and subdivide. So we can hold this, this side, and similarly we could have done to the other side. Often in these types of objects, if you wanted just an even edge loop all the way around, there's a little, like if I select this face, shift double click to select this entire face path all the way around the object, I can extrude that and use, in this case, the thickness a little bit to drag that out, and I get one edge loop going all the way around the object, very evenly distributed. And if I wanted to have 3 edge loops, if I wanted a very tight corner, maybe that's not the case for the spoon, but let's just see. So I extrude again, and this time I'm going to use the thickness, or the offset, or just going to scale it, or I'm going to use the offset, yes. Okay, 0.2, let's see, so 0.05, or not, 0.1, or not. Let's see. So yeah, in the channel box we also have, this is the latest extrude that we did. So if you want to find the offset, it's here. So if you want to be more precise, you can enter it numerically, or again, you can use the middle mouse button there. All right, so pressing number 3, you can see now, well, it seems to be funkiness with my mesh. Yeah, something funky. So I'm going to do that last little extrude again. But just to take away from this is that you don't always have to use the insert edge loop tool. Like in this case, it's easier to select this entire face path that just encompasses the object. Press extrude, and we get that automatically going all the way around. In this case. Yeah, something's wrong with my mesh. I don't know what I did wrong. Now it's behaving. Okay, so but I would sort of, you can work with the shape a little bit more before we do that. So, and this is what you're going to spend your time doing. This is where you're creating the shape. So you'd be trying this out a lot, making sure this shape is as good as you can get it before you continue, essentially. So what I like to do, I'm just going to save this scene. I just copy this over here. So this is, version 1. Let me freeze this first. So if I ever need to just quickly revert back to this one, it's right there. I can grab it and just zero this out, and then I have it here again. But let's move on. So I might want to have some more, you know, maybe I need some more resolution in there to achieve this shape. I think. So what I'm going to do, I'm not going to necessarily do the creasing edge yet. Sorry about this. Gonna, this is going to be you later. You know, you're going to be fiddling around. You're going to be trying to find solutions, which is a lot of what you're doing. So probably just going to. So you just have to sort of force these words to behave, try different things. You know, don't be afraid to grab the words. You know, it's going to seem a little messy, I think, when you start. And here, maybe I need more resolution. So there's several ways of doing this. We could have. Well, let's do that later. But for now, like when you need more resolution in this area, one thing I can consider doing is just grabbing all of these and extruding, making this and offsetting this inward. Right, so I'm just extruding this whole entire area. So in effect, I'm creating a new, what we call edge flow. So if I select the edge loop tool, you'll see that now there's an edge flow going around the spoon this way. Right, so again, this is the area that I got from simply just extruding straight up. Here I want more resolution, so I'm thinking, okay, I'm just going to grab, shift select all these, I'm going to extrude, I'm going to offset that inward. And then I can keep going, I can offset it again if I want to, and then push it down. Right, working with it that way. Subdividing. So this is it. So you know, I could be experimenting with this top. Okay, maybe I wanna try to keep this loop looking more like that. Maybe I want to grab these words, push them down. So this is again, this is where you spend your time creating the shapes. You know, experimenting. Okay, so fine. Let me just try to. Actually, I might want to. Let's just do an edge loop in this case around this. Come on. Excellent. Oh no, never mind. Beautiful. And then remember, so I can grab all these and play around with the scale. Again, grabbing all the vertices sometimes is the easiest way. So you could do a lot by grabbing the verts, I think. And let's see, what else? What else? Any questions? Yeah. Yep. Center of the grid, or yep. So that's a funky solution in there. Kind of not happy with. Okay. Yes, you go to the edge loop tool. You can double click the icon and then go to multiple edge loops and then press 1. So if you have 1, makes no sense, but that's going to put it in the mathematical center of whichever path that you're doing. So it just finds each polygon it encounters is going to place it in the middle. Yeah, so I'm not liking this too much. It's okay. So what we have here, though, is only quads, which is nice. Arguably, this is starting to get a little funky. We get a sort of a unnecessary complex shape in here. But yeah, right. So cool. Let me think if there's anything else we do. Well, so I'm sorry, you're gonna be bored a little bit. I have to try something out. Explain this. No. So, yeah, just for the sake of demonstration, I'm not going to spend too much time on this, but sometimes you need sort of a creasing edge in some parts of the mesh, but not in other parts. And this is a problem that you're going to encounter a lot when you're modeling this way. So the spoon is an example of this because we have one single mesh and it needs to be one mesh, right? It's not going to look very nice if the top of the spoon is a separate mesh from the bottom. I mean, this is a very nice one piece. It needs to be one mesh. But we might have different needs. So let's say we do need an edge loop going down here. So let me just, to keep the curvature down here along this, corner. But then we don't want it up here. So let me do this again. So, all right, so we insert an edge loop, but it goes all the way around. So when I hit number 3, it's going to create this shape, which we don't necessarily, let's say we don't want that up here. We just want this more rounded off, but we do need it down here. So then you can literally just, what I would do is just insert the edge loop, and then we can get rid of, let me just check this. We can get rid of the parts of the edge loop that we don't want. So let me go to edge mode, and I can click and shift double click. That's going to select that portion of the edge loop that we just want to get rid of, and then control backspace to delete it. Now we have what we want, but we have to address this issue because whenever you start just deleting edge loops, you're leaving behind some unwanted polys. So this one right now is an n-gon because it has 1, 2, 3, 4, 5 edges, so we don't want that. So whenever you do this, that becomes a question of, okay, so how do we now solve this so that we're back to preferably an all quad solution, right? So what I can do in this case, so again, there could be several solutions to this. You would have to try different things. But here I can go to, again, what we saw last time, the multi-cut tool. So that's almost like the insert edge loop tool, but it's not. I can draw edges wherever I want. So I can draw an edge there. So now I created, so far I have a tri here, and I have a quad here. Okay, so you never want n-gons, so we never want polys with more than 4 sides. That's something we never want. You can actually have tris sometimes. You just have to, essentially you have to make sure that it's not causing any unwanted desires when you subdivide, sometimes even a few tries can be preferable in some cases, but for the sake of simplicity here, I think generally we try to avoid it. So let's say we wanted to get rid of this try. We want to make this a quad. So this always becomes like a bit of a, you have to try this, but if I just insert a vertex there, now this is again an n-gon, this would be a quad. So you see, it's kind of difficult. If I start placing this, yes, now that's a quad, but now this is an n-gon. If I place it over here, now this is a quad, but now this is a trie again. So if you have this case where you actually have two tries, because we have a similar solution on the other side, we can connect the two tries, making both of them quads. So if I went around here and eventually did the same on the other side, let me rather insert an edge loop in the middle of this spoon. So in this case, I'm just going to use the cut faces tool. And I'm just going to draw this out holding shift and snap this thing. Holding X, snap it to the middle of the grid. Then I'll delete the half that I'm not done with. Whoops. And I'll mirror this in negative X. And we gotta be careful with the merge threshold. So 0.05? Nope, 0.01. Yes. And you can see that, again, maybe you have to try this, but now this is a solution where we have, this is a quad, because this is coming in here, just making that a quad. 1, 2, 3, 4. This is a quad, this is a quad, and we have the same solution on the other side. So it's just like we created a new edge flow again. So it's kind of hard to see maybe, but if we did an edge loop going down here, you'll see that it's following this path. Right? So this is what is sometimes required when you have one continuous mesh. Oh, this is messy in here. Let's get rid of this. So you have one continuous mesh, but you have some you're inserting creasing edges that you don't necessarily want in all parts of the mesh. So, any questions about that? So this is where you'd spend more time shaping this, making your desired shapes. That's what really takes time. But I think this will cause more elegant solutions if you try to think if you can't start off flat. So if I place these side by side, this is sort of this is the evolution of the spoon. So this is what I want you to do in your scenes. Like if you can just remember to take a copy. So when you're happy with the first stage, just copy it, push it over here so you have it there. So quickly, if you just want to revert back to it, it's right there. And there was also a stage before this where it was completely flat. So this would be like the second one because I'm starting to think about the other, like the Z dimension, the depth, right? And then it progressed to this and then to this. There's a re-topology tool, yeah. Yeah. So typically, okay. So all right. Yes. Depending on your workflow, so retopologizing is something that you typically do if you start out with a sculpt, let's say, or something, because you can do it here. It would be like first modeling it and then retopologizing it. is something I think you'd find not very often. It's just more like it's not going to take you longer to just think about two things at once when you're modeling simple things like this. I mean, it would just take you so much longer. Right. Okay, so let's take a 15-minute break and we'll continue. All right, we're going to roll on. We're going to make a plate. Okay, let me open up the spoon again. So here I have the scene with the spoon. Everything's in here. I'm going to export this mesh. So whenever you're pleased, you make sure that we always model centered in the grid. The width axis is the x-axis. The front axis is the z-axis. This is the way it is. And then you freeze the transformations. You delete the history. And the mesh is clean and supposedly okay. So we're going to get back to this, but there's a little checklist, which I'm not going to do in here. The TAs will do that on the lab with you. You can also do a cleanup function. So here you can actually do. So let's say I can make this select four-sided faces. So that's going to select all the quads. We want quads. Yes. But now I can shift invert that selection, and it would select anything that's not quad. So if I hit Shift I, you can see that would isolate anything here. It doesn't happen. So this is all quads. Let's make, if I delete this one, now I have an n-gon there. Let's see if it would detect it. So I can go here, Mesh, Cleanup. It's going to select, so it's set to cleanup that's just going to fix it. But I'm just asking it to simply select the matching polygons. So it's going to select all the four-sided faces. So then I can Shift I. Oh, it doesn't do it. Oh no. Really? Oh. Invert. There, it did it. Okay, Shift I. So it should isolate anything now that's not quads. So that you should really make a habit of going through the cleanup when you're exporting final meshes, because there might be some little errors that you didn't spot. And yeah, other things, but you'll go through that a bit later. So we'll send this over now. I can save this out. There's one format called OBJ, which works. It just stands for object. And it's a simple format. It's just all the geometry, all the UVs, and the normals. Basically your mesh. Let's see, where is it? Oh, so I have to, here. So for some reason in Maya, it's not activated. So you have to go into the plugin manager to activate OBJ export. Anyways, I'm not going to save OBJs now, but just showing you, this is the most common format for meshes. So OBJ, we're going to have to hit load. And that's it. So to do that, go to the plugin manager, which we sometimes have to do. And then you have to find OBJ export. Okay. That just means that when I now go and export selection, this will show up as OBJ here at the bottom, OBJ export. Okay. But I can also just select this and save export selection and do an MA, for instance. So this could be, not the spoon where I'm working, but this could be sort of the spoon asset. Okay. Spoon as, fine, all right, whatever. New scene, don't save. And I can import the spoon as into here. Right? Just import it. Very nice. So there it is. It's in the correct placement and in the correct scale because I set this up and I deleted history and everything's nice. Yep. All right. So let's make what's next? A plate. Let's make a plate. How do we make a plate? Well, we can go to the polygonal primitives to see if there's anything that will help us out. I'm not going to spend too much time on this. So let's just make a cylinder. Go away. And typically, like when you're dealing with circular objects, you might say, yes, this looks nice. It has enough definition. Wonderful. But when you're working, it might be better to lower, like intentionally lower the resolution so that you're not left with too many of these edge loops. So I can go into the input and I can just enter 8. So if we keep this to even numbers, typically the way to go. So 8 is, I think you'll find often that 8 is a good number for subdivision axis in like circular things. I don't know. Okay, so anyways, so I can do the same thing. I can actually just get rid of these if I wanted to. I could extrude this in offset mode, offset this out, and just start shaping this. So offset. So there we go. What's that? Yeah, it's pretty. And then, I'll delete history. No thickness, but then I can go and extrude this whole thing in object mode and create the thickness. Boom. Maybe I want to grab. Okay, so quick way to select this. Let's see. Yeah. All right. So I don't know all these workflow things. I can select a single vertex and then I can control right click. If you in Maya, if you control right click and hold, you can change that selection to another type of selection. So if I do this quickly, I just select these and then yeah. So what do you call that button? What's that little button right next to the what? Yeah, more than yeah. The one that's right next to the left shift button. You can hold shift and that one to grow the selection. So, instead of going around selecting these, well, it wouldn't take that long, but whatever. So, but I can do this and then select the faces and then grow that selection and I have all those selected. And then I can scale them apart from each other. So I'm actually scaling the vertices apart from each other. So if I want some more depth, subdivide, see what I get. Again, this probably requires you to spend more time experimenting. But up here, I could do creasing edges just to hold that curvature on the end. So if I wanted more of that kind of a look, maybe I actually want to keep this down here. Let's see. So got to be careful when you're selecting so that you're not selecting through. Then I can offset this. Let's see if I want to try to grab this guy and extrude it down, whatever. Just try something. I don't know what I'm doing, so whatever. Fine. Maybe that'll work, and then we'll scale that up. Now this is my plate. Wonderful. So it looks okay. Yeah. Fine. And then subdivide, it looks nice. So the difference between subdividing, so pressing 3, right? So if you're creating LUI, we were talking about this over the break. So if you're delivering an asset for a final in-game asset, let's say, you probably want to stay clear of having it look at this faceted on the edges because this looks nice when we subdivide when we press number 3. So in Maya we can just subdivide and then hit render and fine. Typically but we'll get back to this because we don't really want to UV map a version that's this crude. So eventually, like you need to probably then do a final smooth. So we're committing more to this shape. Now this is getting extremely funky in here. But anyways, so we're committing more to the shape. So this would be more of a finalized asset. I would smooth it even more to get more edge loops. But then you wouldn't want all these in here. So you get rid of a lot of these. What I'm trying to say is that you got to keep working with it. It's not an automatic process. So even though I've subdivided, I hit smooth. I don't have to be happy with what I'm left with here. I have to keep working with this. I'm getting rid of a lot of the unnecessary edge loops because now I have too many, but I need even more because I want to keep it. So I would probably do like even more, now we have a crazy amount in here, so I could go over here and say, well, we get rid of all these, control backspace, and look at this. This is totally nuts. So then all right, so then let's go to the hotkey editor, and then select, where is it, Polygon select. Yes, select edge loop. I'm going to do that on Control L. So now I have a hotkey. Go away to select. So if do some of these, get rid of all these. Don't need the Control L, Control backspace. So you see what I'm saying? This needs to be fixed, but this whatever. So but now I have enough this way, but I'm cleaning up the ones that are superfluous because they just happen to be introduced when I did the smooth. Sorry about that. That's horrible. Anyways, let's not spend more time on that. So go away. Undo. Yeah, thank you. Okay. So I'm going to be happy with this. Let's place the spoon there. That'll be fun. Let's go down. Nice. Let's make a cup. Can we do some primitives for it? I don't know. Maybe. What about this one? And yeah, I'm just gonna probably just work flat again, just because. And I'll just make the shape. Whatever we want to do. Okay. Actually, I'm gonna, again, like I told you last time, I would actually work with a lower res. So working with the verts, holding control to scale in the other two axes. Okay. And then I'm going to fill that hole here. I'm going to use fill hole. Fill hole. Now that's a huge n-gon because we have all these edges coming in. A lot of edges. There's a big n-gon and we have to fix it. What do? We go to the multi-cut tool again and we can start cutting. So I'm paying attention to the axis. So the c-axis, probably you want an edge loop along the dividing line, right? So there we have. These are actually now quads. So then I could grab these and I could just extrude this inward. So we still have a completely flat, like there's no thickness to this cup, but I'm working out gradually, just quickly, the topology and the shape, which is just beneficial to do in this stage, I think. And then if I wanted thickness to this, go away. I would go Control E in object mode, do thickness. Now this has thickness all the way throughout. Let's take a look inside. This is the way it works. So in this case, we're nowhere where we're looking at this cup are we looking at the back faces, right? It's an okay solution. When we subdivide, it's going to look like this. We're going to need more creasing edges up here. We need a creasing edge down there to keep that shape. And we need a creasing edge up here and one there and one down there. And we can, there you go. Just to keep all those corners. So I can still alter the shapes here quite a lot, again, by accessing the vertices. So if I go vertex mode, I can grab all these verts, and I can hold control, and just scale. If I want to make a lamp shade, that's nice. Just to get rid of that. So, okay, fine. Let's make a handle. So typically, when we're dealing with a little bit more complex shapes. So a cup is actually a little bit complex if it has a handle, because it needs to be one continuous mesh. We will subdivide it, but uh, often it's very helpful to analyze it a little bit and see if you can't divide the task into separate tasks, sort of. So this is the main body of the cup. Then we're going to make the handle, but they're not going to be separate pieces eventually. But just for my uh, for for simplicity's sake here, it's easier dividing it in two tasks and then trying to connect the two meshes and then merging them together. Okay. My thinking here is that I probably need more vertices or more polys here. This will, let me just do, this is going to make sense eventually. All right. Let me just do it. So to help me out with the shape, I'm just going to probably make, I don't know. Yeah, I could make another pipe. Yeah, make another pipe. And then, you know, here I already sort of have the shape. And then I could try to minimize it again. Just don't have too many, because I'm keeping this intentionally low when I work. You know, I don't want too many. I don't want to introduce too many segments in any of these pieces, because I will eventually subdivide it. So when I subdivide it, it's going to look better. So this is the only portion that I need. So select that first, shift select the rest, and delete it. So this is still just half, you know, same thing I'm always doing. And I can place that here. Maybe I want a little more. So go into here, subdivision axis. So yeah, something like that. So that's nice. Maybe, I don't know. All right, not happy with it. It needs to be thinner. I could do that in the torus primitive, or I can just extrude this out, and now it's a little bit thinner. And then I could delete this. Yeah. Anyways, so I'm gonna extrude this too, probably. So just have some ends here to attach. Then I can hold X to snap this word to that one. Let's see. No, I'm sorry, V to snap to points. I can hold V to snap to this point. Oh, this is too funky. Help me out, cup. Thank you. All right. Okay, whatever. So should have had, granted, I should have done a reference search for this. It's a little funky, but fine. So now I need some, some faces to attach to. So instead of explaining everything, let me just say that I'm copying this over here. I'm just committing to the shape. I need more faces. I'm committing to the shape, meaning, you know, I did the creasing edges so that the curvature is nice. You know, these extra ones up here that just, and down there and down here, that just keeps the curvature. Now I need more faces over here. I could start introducing some edge loops. Matter of fact, I'm gonna probably introduce some. So multiple, just have maybe, I don't know, let's see. Let's see what happens. So maybe if I smooth this one, right? Now I have more faces. Does that make sense? So what I mean is I'm committing to the shape. Like I'm working simply, I'm subdividing, but then I need more, at some point we need more details. So I go, can I smooth it now? Okay, I'm committing to the shape. I have more, I'm smoothing it in division 1, which means it's going to quadruple the poly count. Gives me more vertices to work with, or more polys to work with. But before I did that, actually, what you saw me do, right, I introduced just more edges, just so that it was a little bit more evenly distributed. So I did like this. before I subdivided it, which makes a whole, actually, yeah, here. So where's my original one? You know, that's the way it was. Let me try to smooth that. Oh yeah, so right. You know, so it's much less evenly distributed, right? This is the smooth after I introduced some additional edge loops. This is the smooth without it. So you can see that I get a lot more going this way, not a lot going this way. So just for you to get an idea, it's nice to think to average out your poly spacing. So you want to introduced some edge loops deliberately before I did the smooth, because once I do the smooth, it's going to quadruple everything, right? So, anyways, and now I have some more polys here to work with. So this becomes a case again where we have to start massaging the vertices, and you know, you have to be experimenting a lot probably to get this the way you want. So here, though, what I see is that probably I'm going to need, I look at it this way. In this region, I need more detail. So I'm going to probably, okay, so one nifty tool is the slide edge tool. This one. Let me add that to the shelf right away. So because if I grab the edges and I start moving them around, I can move them, you know, around like this, but they're not following the contours of the object. So a quick way to do that is just I select these edges and I activate the slide edge tool, and I can hold middle mouse button and just drag, and it's going to keep to the contours of the object. So if I just wanted to move those up a little, it's better to use the slide edge tool. So fine. Then maybe I can use this one. I'll slide those down a little. Then I can grab all these polys and I can extrude and do an offset. So again, we're creating a new sort of edge flow. And then I can snap these up here. Let's see. I'm going to snap these along the z-axis to those. Oh, right. Hang on. All right, let me move it down a little bit. I'm holding middle mouse button when I'm in the move tool just to. Hang on. Actually, sorry. I just need it over here, right? Yeah. I don't need to extend that extrude all the way down. I just need it here. This is the sort of, you know, tinkering around that you're going to have to be doing. Let me get rid of the half here. I'm sort of just creating an area in which this handle might be extruded from. A little messy, granted. But I'm making use of the snapping functions a lot. So I'm sort of snapping to the verts. But you see there, I have this little, I can delete that. I can extrude this guy. Let me reverse the normals. just so it will extrude the right way. I can actually hold V or X, actually snap to the middle of the grid. Then get rid of these. So you see, this is just gradually how we could, I mean, there's other ways of doing this. I could have extruded this along a curve after I made this, but I think sometimes you'll find it easier to do this. It might not be the case for the cup, but that you have to sort of divide the task into different tasks and then connect it together. So to sum up what I did here, and I was sort of not nailing it on the first one because I did an extrude all the way down, which was unnecessary. But essentially, if you have something, I just did an extrude basically from this polygon that was here, and then I moved the verts to match this guy. Right? That's essentially what I did. So then and then I would now combine these. So in my, okay. These are technically separate meshes still. Like they're one object mesh in Maya, they're one object, but they're technically two meshes because they're not merged together. So Maya will recognize this if we go to separate. So you can see that I open up the outliner and this is, this is now one because I just combined them. But if we go to separate, it's going to separate it back into two different meshes. What we also have to do when we do that is just delete the history. Then I can Shift P, drag them out of that group, and now they're two separate meshes. But in order to merge these together, what I first need to do is combine them. So there's separate and combine. Now they're combined, but they're still not merged. So if I subdivide, you'll see funkiness. But I will merge. So merge components. Oh, there's also another nice little thing. If you go to display polygons border edges, it's not very well. You can make them larger, I think, but you can see that the ones that aren't actually merged, that edge is a little bit thicker. And there is a way to set this up so the border edges would be even larger. But anyways, you would tell if you subdivide anyways, those are obviously not merged. Oh, and we have to get rid of this face inside there. Then we can merge, 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 and subdivide. So now it's sticking together. And let's just do the same thing here. I will extrude, I'll do an offset. So, and actually I don't need this. I'll snap both of these to, by holding V, I can snap it to these. Now we have this guy where this will be coming out of, right? So I can delete that face. We could have used some other tools now as well, like the bridge or something, but I kind of want you to just do this. Because it works. And then I'll go over and merge. So in Maya, if you want to use the same tool again that you just used, or the same operation, because I just merged, I can press G. So if I go like G, I'm just merging again. So I can merge several ones at once. Also, there we go. And then, this transition and the way this looks aesthetically is something that you would have to keep massaging. It just depends what the mesh looks like. Obviously, the distance between here. If you wanted maybe to experiment with having an edge loop there, like what would that look like? What would that do to the subdivision result, etc. So you see, even like a simple shape might take a little bit of attention and work because we're sort of doing two things at once. We're dealing with the shape and the aesthetics, but then we're also dealing with the topology and making sure that we have an edge flow that works. And so the topology is in some like this pattern that all the polygons make out. So we have, just because we've just been extruding, working gradually, we have an all quad solution still for this half the cup. Maybe it's going to look funky now because it's going to be very thick. Let's try. And mirror geometry. This in this case is minus C. So over here, we're gonna so we're gonna do something to that. Minus 1. The handle now is looking a bit funky, so I'll probably want to make that thinner. Go to this view, and I can just grab these verts. Make sure I don't select additional ones. And just scale them towards each other. All right. So that's sort of the evolution of the cup you see here, where, well, actually we started with a very flat one, which I guess we can do by merging all these with a large enough threshold. Come on. No? No. Okay. Never mind. All right. Any questions? And you see, I mean, this subdivision might be a little, maybe we'll have to spread this further apart or something. This is where you have to keep trying. So we can also activate the polycage, like this, to see the actual polygonal object and the subdivision result at once by pressing Q. Okay. Excellent. It's too thick, my spoon, right? Okay, what time is it? We don't have time. Yeah, I want you to do a teapot. It's going to be the same challenge as we just did here, right? I mean, that's the main thing. Are you familiar with the teapot? The Utah teapot? Anyone? What's the Utah teapot? What's that? Where's the original? Is this it? I think this is the original. So the Utah teapot was just like made by, who was it? Newell? One of the the CG basically gurus, the founders, the inventors of everything. A lot happened in the University of Utah in the 70s. So this is just one of the models that was made during that time. If you see, that's not the original, is it? No. Anyways, but this one is not actually in one mesh, so you can see that it's just a hard transition between the different things. I want you to next week. You're going to be watching the Pixar story. So I don't know. The TAs will arrange for a screening. You will have you get to see sort of the history of CG with Ed Catmull, who's now the CEO of Pixar, but he was one of the guys at the University of Utah in the 70s. Also, the CG, there's a book that's on your recommended reading list. There's two. There's one CG history book, and then there's Creativity.Inc., which is written by Ed Catmull. It's just, anyways, blah, blah, blah. So it's kind of an inside joke now. So there's a lot of teapots everywhere, but it stems from sort of the Utah teapot. But it's a nice little challenge, anyways. Like Adrian says, there's a lot of intricate shapes, and it becomes a challenge when you're, especially if we want to do it in one mesh, right? Well, two meshes. So there's the lid and there's the body. But it helps if you tackle the challenge. You have to look at it. Okay, there's the body, there's the spout and the handle and all these different shapes. So you can sort of tackle like we just did with the cup. I think that's going to be a little bit easier for you. So unfortunately, I don't have time to do that now. I wanted to do it, but I'm gonna. It'll be the same challenges with the cup. Let me save this one as this. Actually, but there's one more operation that I want to show you. So then we're going to go over to surfaces. So you wouldn't necessarily have to do this, but I think it's going to be a little bit easier, especially for the teapot. So it's the last little thing I think I'm going to show you, but I do want some sort of reference for this. It's going to be a little bit easier. Come on. Okay, so all right, so in the viewport 2.0, you won't see the actually. That's all. So you got legacy high quality. You want to if you want to use this way of importing reference images. So if you go to the front view, you see I'm pushing this back, which works, but to see the grid lines, you have to just go from viewport 2.0 to the legacy high quality one, which is fine. All right, just so now we're in front view and we have a reference image. This is what I want to show you. It's not an orthographic image again, so there is perspective. So we're gonna have to guesstimate the shape a little bit. That's fine. I want to show you. We're gonna, like I did this morning, I can now draw an actual curve using the CV curve tool. And this looks like a fairly easy shape, but let's just try it. So I'm going to hold X to snap to the middle of the grid first for the first curve point, and then start drawing the curve. Why is it not showing up? Oh, there it is. Okay. So again, there's perspective here, so I'm not going to follow this too closely. But I'm just drawing curve points, establishing this curve. And whenever I have a bend in the curve, like a sharp bend, I just place points closer together. But I think of it in terms of, to actually define curvature, you need 3 points. So at least 3 points like for each bend. That's sort of my thinking. And this should probably be like, let's see, nope, control vertex. So the control vertices aren't showing up. That's weird. Okay. All right. So in the legacy high quality, the control vertices won't show. Whatever. Go to viewport. Yes. Okay. So yeah, spend time doing. So this is what we call the profile curve. Just outlines the contours of the main body. So again, I'm just simplifying the shapes, and I see that, well, this will require some attention on its own, so will this. But I can quickly just get the body, and then I can tackle this just like I did with the cup. But in this case, instead of starting out from a polygonal primitive, I'm just going to do this operation, where we first establish the profile curve, and we're gonna switch over to surfaces. So I think in 2016, that's on the labs. There, you don't have this, right? It's all in modeling. Unfortunately, this is still on the old Maya. But you find the revolve option, which shouldn't be too tricky to find. It's like the NURBS revolve, and it's gonna revolve the curve's surface around the curve. So what we're looking at here is no longer a polygonal primitive. If you right click, you can see that this has different components. This is in Maya, what you call a NURBS object. It's like a curved surface. But we just quickly did this to arrive at this shape. So let's say, okay, fine, it's going to be a flat one. We're kind of used to that now, like working with flat geometry, doesn't have thickness. But it's still a NURBS object, so I'm going to have to make this into a polygonal primitive. So I'm going to go convert NURBS to polygons. And then what I do, I go to the options here. So I set this to control points. That's just going to give me a direct translation from the CVs that I placed. Those are now going to be the basis of the vertices. So I think this is the most straightforward option, and then just apply. That will give you the exact same result. Now, you might say, well, that looks ugly compared to this beautiful curved surface, but then you can subdivide this and you won't be able to discern the difference, especially if we go into the attribute and set a higher preview. So now it's subdividing these a ridiculous amount. And we can toggle between them, the benefit being that we can still alter the mesh, like we can do extrusions. So if I go in here and I do this and I extrude and I do an offset, and I'm not going to do this time, but just quickly, you get the idea. So we could do whatever. Yay. Okay, and then subdivide. That's obviously the benefit. And with NURBS, we cannot. I'm done. Right? So you get the idea. So yeah, so convert NURBS to polys, and I use control points. That's the easiest one. And then we're left with a standard polygonal object again. And I can get rid of these. This is it. And this is now the basis of my, But okay, so one thing you have to be careful with, the middle point I don't think is going to be merged. So, no, so there's 8 vertices. Because we have 8 incoming edges, like for that middle point. And you can't really see it when I subdivide even, because they're just meeting in that one point. So this is something you would just have to, know. But the middle point, then I would just go and merge it to have a nice mesh. So back to polygons, I'll go merge components. Now you see in the poly count, there's 1 vertex. And yeah, delete history. set this back. Now, eventually, you know, I can keep working with this. I don't have to add thickness yet, but eventually we don't want to see the interior being back faces. We never want to see back faces, so we want an interior. So an efficient way to do this, just go to object mode again, extrude in object mode, and we'll create some thickness. Now there is thickness in the object. Go inside, have a look. Yeah, there's an interior, and then there's the back faces inside the object, and then there's the exterior. So for a lot of these complex shapes, like, it's much easier working flat and then adding that uniform thickness in one operation. So, okay, so I'm gonna leave. That's nice, anyways, right? You don't have to see me doing everything. So this will be your little challenge, just like we did with the cup. You need to spend a time working on the spout and the handle and everything. And all right, quickly let me create a lid, just because I want to make this point, is that you can sometimes just use the existing object. So if I make a copy of this, because we already have this shape here, so I can just go select that shape, then let's snap this interior edge to these verts, and then I'm gonna scale them in. Then I can fill that hole. Then I can go boom, 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 boom. Oh, sorry. Just creating quads in the middle and extruding up. And there's our lid. And we can grab these. So just making the point that you can make use of existing geometry. You don't have to reinvent the wheel, right? Just think about it. Is there anything here I can utilize? So now we have two different meshes, and that's the final solution. There's going to be two meshes in the teapot, but obviously this is a more complex shape, and you would have to spend a lot more time building it. All right, but this is my teapot. Beautiful. Okay, any final questions? Yep. Yeah, so the deliverable for Friday, you're not going to be delivering physically because we don't have the server up yet. So the TAs will go over this with you today, but essentially you're going to have to start. You will finalize the concept for whatever it is that you're doing as your mandatory asset, right? That's the mandatory. For Friday is that you work with the concept or finish the concept, which could be external concept art, you know. So the way this will work is that next lab session, not this one, but the next one, you will present this to the TAs. They've done this before, you know. They know they're going to be able to tell you, is this a good? Do you think this is a good solution or not? So it's just going to be an informal, quick introduction that you're going to do in the next lab session, because it's really up to you. The only thing we're going to care about is if you're trying to do something that's too advanced for this course or something that wouldn't really be enough. Right. So that's as far as the deliverable. It's not really a big deal. You just really have to make sure you start, if you haven't already, finalize the concept, do a lot of reference search. I think there was one more thing. No, we did. All right, so we did this. Yeah, I think you'll be fine. Let me think. Let me think for a second. Yeah, no, I mean you'll be alright. It's just I really hope you see the benefit of sometimes working flat. You know, because I often see that a lot of students sort of disregard that little tip, and they work from cubes or thickness. It's just harder to do because it's hard to get nice uniform thickness. So if you have a very complex shape like the one I'm building here, maybe sometimes this will curl and do crazy things. If you wanted something like this to have thickness, just in object mode, do the thickness. You get a very nice uniform thickness, and then I can grab this face path and I can extrude that. Do a little offset, a little thickness, and a little offset, so just to get those creasing edges. So we get this shape. That's very hard to achieve if you're starting out from a cube. Like if you're starting out with the thickness, it's much harder to achieve this uniform thickness all the way throughout. There is an option to create a cube, or I'm sorry, a curve again, and then let me quickly show you this. So if I do a CB curve tool to do a curve, and then I can extrude this, shift select the curve and just do an extrude. That's going to snap this to the end of the curve. Then I have to add more divisions. And then I could do like a taper. I could do twists. It's pretty cool. So we can talk more about the extrude along curve, but you can make use of curves. This is just about you starting to experiment. You can achieve some very complex shapes very easily, or in a more elegant way. Because if you're starting out like this and just keep going like with a box modeling approach where you have thickness, sometimes that's helpful. Where you always have thickness, and then it's just harder to, I'm not making my point very nicely, but whatever. You get what I'm saying. Thank you.